YouTubers, with another update. As shown before, my first bank 4.7 kilowatts, my second bank just installed 4 kilowatts. They are connected, this bank parallel to this bank, so positive to positive and negative to negative. So to make sure when we put these together, each bank has to be the same value as all the others. Because if not, if one is too small of a value, it will charge before the others and overcharge. Because all the inverter wants to see is total voltage across the 7 banks. To do that, I'll use the spreadsheet. When that focuses in, it will show you each bank corresponds to the banks here, and as I put in the value for the cell, which is done on a discharge of 1 amp on one of these, this is a letter color 500. Every time I put the cell value here, it gives me the total, the average, and then that adds up the total milliamp value for that pack. And then as I'm working it out, it gives me total kilowatts total for all these banks together. So basically each line you add it up and it gives a formula. So that's the formula, obviously each cell plus the next one, and then divided by that number there, 80. So you can get each bank pretty much spot on. These are in milliamps, so for argument's sake, bank 3, 1923 milliamp. Average cell. That's very important because that's what determines if your packs are going to charge and discharge at the same rate. So what I did was, to make up these banks, I have used 10mm electrical wire because I have a lot of it and it was easy to use this, and it was cheaper obviously because I already have it. 10mm electrical wire is about 50 amps. So what you work out is, if you've got 7 banks and you draw in equally over the 50 amps, at maximum you're going to draw 350 amps from the total. And obviously the inverter, this one, is only rated 142 amps. That makes that bus bar more than adequate. Then if you add in a second bank like this, it's obviously divided over the whole lot. So what I've got to do here is, I've got to strip out this one here for now, because that's an AC breaker from my panels, and I have the right one, which is a DC breaker, 50 amps. So that's what I've got to upgrade. Soon I'll be taking out this self-resetable 50 amp fuse, which actually trips at 80 amps, so I can actually run higher wattage equipment in the house. But yeah, so with the bus bars, what I do is, very hard to see, that little wire there on the positive is fusing wire. I use 1 strand of electrical extension cord, because there's 32 strands in there. 2 of these strands, dead short over 1.8 amp battery, would fuse out. So obviously it's adequate for what I'm doing. Any of these values I'm telling you is what I found. Don't go by them as accurate and true. Source out this for yourself, because I don't want to be responsible if anything goes wrong on your system. But on the negative side, if I can get into it, that is 1 strand of 2.5mm electrical wire. That doesn't have to be fused. If you fuse both sides, you'll be a bit safer as long as you've got one fused. So now this is up and running, it's working. The cable here I'm using is 170 amp cable, which is well and truly okay for this inverter, but eventually I'll update everything and I'll go to 35mm square. I have to replace this one because that's that 10mm electrical, which that's what that is. I've got to replace that with that when I get it, but for now we'll do the job because obviously it's going to hold enough, it's got enough there in it to hold the current I'm drawing. So what you do is you size up how you're working out what you're going to run off it. So your 10mm fuse wire, important. So anyway, now on paper, this system is 8.7 kilowatts with running a 3000 watt inverter to the house. This setup now, since my billing cycle started, I'm only using 6.25 kilowatts of energy from the grid, and that's still dropping because we're coming into summer here. Just to give a bit of an idea how to read this inverter, at the moment it's set for the input for the batteries, how much amps are going in. It's night time, so there is no solar, and the output is this side. But if you're using this software, what I found is on this side here, this is the power generated from the solar, the battery voltage, battery capacity, which if you're running lithium, don't go by that, it's not accurate, and that's PVC or PV input current and battery discharge current. So what that means is, what I found is, if you're generating so much power off the solar panels, first it goes to the house and the remaining it goes into the batteries. And that's what that figure is, the remaining that's going into the battery. So if it says 20 amps, you might be putting 10 into the house, you got 20 left over for the batteries. So that's what that means. Same with the discharge. If you haven't got enough to put into the batteries, it takes what it needs from the batteries after it's taken it from the solar panels. So it might only, you're probably putting 200 watts into from the solar panels, and the argument's sake it might be 10 amps going in directly to the house, but it's not enough, it might draw another amp from the batteries. So that's how you read that. So whatever that value here is not all that's gone into the all generated from the solar panel, that's left over going into the batteries. So I had to have a little bit because I didn't understand that first, but it seems to be how it works. So anyway, I swap over that breaker because coming into summer, I want to make sure that it will break if something goes wrong. I don't think that will be because it's AC. Anyway, so what I found with the battery terminals, I put, that's 835, 8mm by 35, so 35 would be the hole here, the size wire that can fit into it, 8mm hole here. I found the easiest way to put these on. These are the little blowtorch, one of these things. You can buy them off eBay, and you just get the canisters from Bunnings or anywhere. They're like portable stove canisters. So what I do is I heat up the wire with the eyelet on it and keep pumping solder into it, try and balance it. Found that's the easiest way to put them on. No crimping needed because there's a lot of solder in there holding it together. Obviously there's a lot more to know about this, and I'm all over the place with trying to explain it, but I like to show how I'm doing, but I gotta work out how to do all the fancy features with video editing, but don't know how to do any of that yet. You could always ask questions how it's done. Same if you want to make these packs, say if you're trying to figure out how to do all your formulas, shoot me a message. I could try to email you that spreadsheet and see if it works for you. But anyway, any more updates, I'll keep you posted what I'm doing. Next week I like to replace this with a decent circuit breaker I'll put here. I'm going to understand how that works because I probably won't need the switch for the batteries, because if I put the circuit breaker, this switch won't be adequate. It's only 100 amps. I'll keep you updated on that, but just trying to get you to understand a little bit how this works, because it makes a big difference if you can understand it. Anyway, any questions, please ask, and I can answer the best I know. I hope any of this has been helpful. If not, let me know what you want to see and I'll try and do it. Okay, thank you for watching. I'll see you next time.